Welcome. As part of the AOS-CX 10.12.0006 update, we now have NAT support with the Pensando PSM and the CX 10000, and this is a small demo to give you an idea of how to configure some of the features. I'm Steve Bartlett, a technical marketing engineer supporting Aruba CX switching. Before we actually go into the demo itself, let's take a look at the feature support for NAT and a look at the demo environment. So let's take a look at a summary of the feature support for NAT. So NAT policy is supported on the border leaf. This is typically how the CX 10000 will be deployed, but it isn't restricted just to this topology, but it is the more common use case. So the concept of connections into the data center are supported by an ingress NAT policy. Likewise, connections outbound from the data center are supported by an egress NAT policy. So in this initial release, static one-to-one NAT is supported. One-to-many or many-to-one NAT mapping is not supported, and dynamic NAT or many-to-one NAT or PAT is not supported. Source NAT on an ingress and an egress policy is supported, and a source NAT on an egress policy will form part of this demo. Likewise, destination NAT on an ingress and an egress policy is also supported, and destination NAT on an ingress policy will form part of this demo. Twice NAT, which is where both the source IPv4 address and the destination IPv4 address of the iFlow, which is the initiated flow, are translated at the same time, with either an ingress or an egress policy is supported, and this can be with or without port translation. And all configurations are implemented on the Pensando PSM. So this is the demo lab setup that I have. As you can see, it's emulating two data centers, DC1, two pairs of 10K switches, and DC2, another pair of 10,000 switches, and host A connects in DC1. 10.10.200.0 is the subnet it's using. On .200 is the IP address, and host B is on 10.10.201.0 subnet /24, and its IP address is on 2.201 for host B on that subnet, and they're both using a VRF IPsec-services at either end. So don't concern yourself with the underlay connectivity model, because that's irrelevant to the demo, because we're focusing on the NAT rules that are configured on the Pensando PSM. So there'll be two rules: source NAT egress policy and a destination NAT ingress policy. So let's have a look at the high level detail of those rules. So source NAT egress, host A connecting to host B. Host A's source IP of 10.10.200.200 is translated to 172.16.200.200. Destination IP remains the same. Now this is for the initiated flow out, and the R flow, the return flow coming back in, will be automatically translated back to the original IP address as part of that rule and that NAT engine process. Now that would be great if all the connectivity model initiated from host A to host B. However, if we want to have host B to initiate a connection to host A, then initiating the iFlow, then we would need a destination NAT ingress rule, and this is where this rule comes into play, because we target the translated host A address of 172.16.200.200 as part of that iFlow coming from host B to host A. And in the real world, effectively, the subnet of 10.10.200.0 would be blocked from the outside world, hence the reason to have the NAT rules in the first place. So down here is the sequence of the services. So outbound of the DC, we have the firewall policy inspection first, followed by the NAT policy inspection, and at the very last service would be the IPsec encryption going out. Coming into the DC, then decryption first, followed by firewall inspection, followed by NAT inspection. And you can have one or all or a partial selection of these services. So for the purposes of the demo, we'll just be using the policies for the NAT. So let's jump into the configuration steps. So let's take a look at the configuration steps then. So first of all, configure the desired policy distribution targets within the PSM. I've already completed that. And if you're not familiar with policy distribution targets, do take a look at the IPsec demo. It does a good overview of the policy distribution targets, or PDTs. But at a high level, all they are a selection, either a single CX10000 or a selection of CX10000s that are grouped together in an entity you call a policy distribution target. You give it a label, and then you use that label to within your policy that you're applying, whether it be IPsec, NAT, or a firewall policy, and you use it to apply the policy to those specific targets within that policy distribution target. And it provides a lot more granularity for applying policy, as opposed to pushing a policy to every CX10000 within the PSM cluster. You can now do it to a more granular CX10000 base. So for the NAT policy itself, we are going to create a source NAT policy, an egress source NAT policy, and the second one will be an ingress destination NAT policy. So a quick summary of those. So the source NAT egress policy client, host A, 10.10.200.200, targeting 10.10.201.201. Original source IP will get translated to 172.16.200.200, and the destination IP address remains the same. And that's fine if we've just got outbound connections from host A to host B. However, if we do have an ingress flow that's initiated by host B to host A, and we've got obviously a deny access to that subnet 10.10.200 on the firewall policy, then we need to target the destination translated IP address of host A, which is now 172.16.200.200. So this is where we have this policy on ingress, where the source IP remains the same, doesn't change, but the destination IP is now targeted by host B is 172.16.200.200 to make this connection complete. If we've got this firewall policy rule in, we then have an ingress NAT rule to translate that destination IP back into the original host A IP address, which is 10.10.200.200. So that's effectively what we're going to apply in the lab. So let's jump onto the lab and start configuring our policies. And this is the initial traffic capture that I've taken with no NAT policy applied between host A and host B. As you can see, 10.10.200.200 is pinging host B, 10.10.201.201, and you can see the request and reply, all using the original IP addressing. So let's go now into the lab and put our first policy on. As you can see, I've logged on to the Pensando PSM, and from tenants I've navigated to policy distribution targets. Just a little bit about policy distribution targets. They're a mechanism to group specific 10,000 switches that then can be applied specifically for a particular policy. So as you can see, I've got a default distribution target, DC1 IPsec with 2 switches in, which is the one I'm interested in for the NAT policies, DC1 switch 1, DC1 switch 2, and another target for DC2 switch 1, DC2 switch 2. So basically the NAT policies will be applied to just these 2 switches in this policy distribution target. Okay, so now we go straight to look at our NAT policies. So now I'm going to navigate to the NAT policies. So from tenants to NAT policies, and you can see there's no NAT policies configured. To create a NAT policy, you just select add NAT policy, and of course I've got to create 2 NAT policies. So the first one is going to be the egress NAT policy, and I'm going to call this one DC1 NAT egress. Let's put that right. Policy distribution targets. This is where the policy distribution target are very, very useful. So I'm selecting DC1 IPsec, which is effectively 2 switches in DC1, and the policy will be, when it's applied, will just push down to those switches. Give it a rule name, and I shall call it egress NAT, and let's call it 10.0. And the source IP address is going to be the target for the rule, which is going to be 10.10.200.200, and the translated address is going to be 172.16.200.200. And I couldn't just match on the source address and translate everything on just on the match on the source address to that translated address, but just to give it a bit more granularity, I'm going to use the target address just as an example that this is something you can do. So that is all we need to do to create the rule for this particular policy. There's only one rule. Of course, you can add more rules as you go through, and I'm just going to create the policy for that. So it's targeting 10.10.201.201, and the source address of 10.10.200.200 is going to be translated to 172.16.200.200. So that is now our policy for our egress, and we just need to do the same and create our ingress rule. Again, I'm going to call it DC1 NAT ingress. Policy distribution targets are going to be the same, DC1 IPsec for our 2 switches. The rule name is going to be, let's call it NAT ingress, and 172.16.200.0. Let's put a double S on that. And don't need to actually target the source address, but we obviously do need to match on the destination address, which is going to be 172.16.200.200, and we're going to translate that back to 10.10.200.200. So that is it. So that's going to be our ingress rule. Effectively, we are going to match the target destination address of 172.16.200.200, and that's going to translate it back to the original source address for host A, which is 10.10.200.200. And we create a policy for that, which effectively will allow host B to initiate a direct connectivity connection to host A using the source translated address that host A uses for its outbound connection. So that's our 2 policies completed. Now the next step is to apply these policies to the VRF. Right, I've now navigated to the VRF panel, the pane, and a little note on VRFs and the switches. The switches that I've pre-configured as a profile of layer 3 core. Now what that means is when you configure the switches as a layer 3 core, they are VRF network aware, not network aware. So when they're VRF aware, what it means is that when you configure a VRF on the Passando PSM, in this case IPsec-services, that matches the VRF already configured on the switches that the PSM is managing in the fabric. In this case, the switches in DC1 and DC2, which it does. They've got a VRF configured for IPsec-services. The VLANs that are attached to that VRF in the switch configuration are automatically redirected to the DSM modules because of the pre-configured profile on the switch of layer 3 core. So just that's a step that we don't have to do, is redirect the networks to the DSM modules. They are dynamically done when there's a matching VRF on the PSM and that VRF is already configured on the switches with the associated VLANs attached to that VRF, and the switches are configured for a profile like LAO3 core. So as you can see, the IPsec-services does not have any policies attached to it, so I'm going to attach our egress policy to it. So I just need to highlight the pencil and NAT policy, select an egress NAT policy, and it's going to be DC1 NAT egress. And I shall just save that, and the egress policy comes up. And what I'm going to do is just jump onto host A and set off a ping from host A to 10.10.201.201-T, and what should happen is then I'll do a packet capture outside of the recording and just show you on a slide of the NAT translation that's taken place, which should be obviously on the source address that we're seeing. So this is the traffic capture from the policy that's just been applied. So just to recap on the policy, we've got a source address of 10.10.200.200, destination address of 10.10.201.201, and the translated source address is 172.16.200.200, and in our packet capture we see that 172.16.200.200 is the request, and the reply from 10.10.201.201 is targeting 172.16.200.200. So that policy is working fine. Before I apply the ingress policy, let's just check that we've got connectivity to the host. So I'm now on host B, 10.10.201.201. Now, of course, I should be able to ping host A to 10.10.200.200, but I obviously shouldn't be able to ping host A's translation address until I apply that ingress policy. So that doesn't work. So let's apply that ingress policy to support that ingress flow from host B to host A with the translation address. So now I'm back on the PSM under NAT policies. As you can see, the egress policy has been applied, but NAT ingress policy is not applied anywhere. So I just need to go into the VRF panel and then apply that ingress policy to the appropriate VRF, which is IPsec services, and select NAT ingress. There we are. It's done, and let's drop onto host B and start that ping off to the translated address, and there it is. That works through now. So what I'll do is I'll stop the recording, do a packet capture, and I shall present that on the slide so we can see the output for both the source and destination IP addressing. So this is the traffic capture after applying the ingress policy for destination NAT. So let's just have a look at the policy rule. So the target address of 172.16.200.200 was translated to 10.10.200.200, and the output for that packet capture, you can see the initiating request from host B is 10.10.201.201, targeting 172.16.200.200, and the replies going through. In the background you can actually see the ping from host A going out as well. But that's all working fine now. So those two policies have been applied, an egress policy on the source address and an ingress policy for destination NAT applied as an ingress policy to support host B connecting to host A, initiating that flow from outside the data center. So that brings us to the end of the demo. Thank you for tuning in.